Hello, my name is Darren Thomas and I am the Director of Educational Research Techniques. In this video, we're going to continue our journey with algebra and we're going to take a look at determinants. So why don't we go ahead and get started. So, a determinant is useful when you have a matrix. And so, it's kind of a summary of a square, of a square matrix. So let me see if I can give you an example here. So here we have I'm going to draw you a 2 by 2 matrix right here. So 2 by 2, and so we're going to have a 4 here, and a -2, and a 3, and a -1. Now, if you're trying to figure out what's the practical use for a determinant, it's kind of hard to give you one. They're used in calculus, and also they're very useful in determining if there's a unique solution for a system of equations. And in many ways, this is the building block for that. Beyond that, I'm sure there are some other ways that this is used in other contexts, but those are the ones that I was able to find quickly for you. Now, in order to do this, and basically what the determinant is, it's a single value that kind of represents the matrix. And again, if it's 0, that means there's no solution. If it's beyond 0, that means there's some solution out there for you. And so how we do this is that you multiply the diagonals, if you will. So if I had to draw this again, it would be like this. So 4 -2, 3, -1, like so. And then all you do is you multiply the diagonals like so. And so what you end up getting is 4 times -1, and then minus 3 times -2. And this will reduce down to the number 2. So that's how you do it when you have a 2 by 2 matrix. Very simple, not a whole lot to that, but it gets a little bit more complicated when you have a 3 by 3. Now, I need to mention, when do you commonly have a 2 by 2 matrix? Well, when you're solving a system of equation with 2 variables. And when do you commonly have a 3 by 3 matrix? Well, again, if you're solving a system of equation with 3 variables. So let's go ahead and take a look at that, shall we? So, I'm going to move now to my 3 by 3 matrix. And I'm going to be a little bit more careful in how I do things here so that it's nice and clear. So I have a 4, 1, and a -2. And then in my next column, I have a -2, 0, and a -4. And then I have a 3, -3, and a 2. Now, we're going to label each column and each row. This will help to clarify things. So this will be A, column B, column C. This is, of course, row 1, row 2, and row 3. Now, here's what's happening. In order to find the determinant of a 3 by 3 matrix, you have to find what we call the minors. Now, what we mean by minors is that you take several squares from the 3 by 3, because the 3 by 3, you can't do all of them at once. And so you take the minors, or you take several 2 by 2 squares to figure out what the determinant is. Now let me see if I can give you an example. Let's say I want to figure out A1 minor. So what is A1 minor? Well, A1 minor is going to be right here. What you do is that you look where's A1? So A1 is right here. And you cross off that row, the 1 row, and you cross off the A column like so. And now you're left with this guy right here. And you do what you did with the 2 by 2. You multiply the diagonals like so. All right? So for A1 minor, we have, if you look closely, 0, 2, minus, looks like we have a -4. And then we also have a -3 here. And so when you work all these numbers out, you're left with -12. Okay, that's going to be important in a second. So let me go ahead and put that on my next slide for purposes you will understand in a minute. -12. Okay, let me go back. Okay, now, so we solved it for A1. Now you can solve many different combinations of minors, but I want to keep it simple. So I'm always going to deal with the first row for the sake of simplicity, because this can get very, very confusing. There are shortcuts in terms of like where the zeros are at, but let's just let's just keep it simple here. So now we're going to deal with B1. And so for B1 minor, I'll just do that right here. Minor, whoops. Let's see here. What am I going to use this time? Well, I'm going to take out, well, this is kind of hard to see here. Let me see if I can kind of clear this up a little bit, like so. So what we're going to do here is we're going to take out the following. We're going to take out column B, like last time, and we're going to take out row 1. We're always taking out row 1 because we want to make our life simple here. We're new to this, so let's not make it complicated. So that leaves us with 1 times 2, negative 2 times negative 3. I hope that makes sense for you. So 1 times 2 minus, so I got the 1 from here, and I got the 2 from over here. And then negative 2 times negative 3. So negative 2 times negative 3, like so. That's what I got. And when you work all this out, you get the answer of minus 4, negative 4. Now, I'm going to go ahead and put that on my next slide. Now, just trust me for a second. This will make sense in a minute. Please be patient. All right. Now, we're going to do C1. So C1 minor. I know this is getting very, very hard to read. So I'm just going to go ahead and erase this. Please give me a moment. Be patient as I try to deal with this little problem here. I'm just going to clear this out. I'm trying to make this as neat and as efficient as possible, and don't want to lose anybody by saying things in a complicated manner. Okay. So let me just rewrite this real quick. So we got 4, negative 2, 3, and then we got 1, 0, negative 3, and then we got negative 2, negative 4, and 2. And this is my matrix. Got A here, B, like so. Now C minor. C minor is going to be right here. So what we're going to do is we're going to eliminate, cross off column C, cross off row 1, and now we're left with 1 times negative 4. So 1, negative 4, like so, minus negative 2 minus 0. Negative 2 minus 0. And you could probably already tell what the answer is. Not that complicated. It's going to be minus 4. So I'm going to go ahead and put that on my next slide. Minus 4. So we know A1 minor right here. We know B1 minor right here. And we know C1 minor right here. Those are our three minors that we found. Now, here's the next thing that we need to talk about. I'm moving to my next slide. What you can do now is that you can take, and this is where it gets kind of weird. Let me see if I can make this simple for you. So I'm going to redraw my matrix on this slide so that you can see it. 4 minus 2 minus 3. And then I have 1, 0, negative 3. And I should have made my box a little bit bigger. And let's see here. Negative 2, minus 4, and 2. So this is my matrix. I got my 1, 2, 3 here. I got my A, my B, and my C, like so. Now here's the thing. There's a pattern that you use, because what we have to do is we have to like add and or subtract these different minor determinants to find out the overall determinant for the 3x3 square. And there's a pattern that you have to follow, and the pattern is as so. So when you ever have your 3x3, you have to follow this pattern. Plus, minus, plus. If you take the first row, if you take the second row, is minus, plus, minus. And if you take the third row, is plus, minus, plus. Now, if you're an A student, you know that we took the first row. So what we're going to do is, now again, this is where it gets kind of crazy. We're going to take the first row, we're going to add across, we're going to take we're going to take the determinants for the first row that we found them. We're going to add or subtract them to find the overall value. Now here's what you do. Again, I'm trying to make this clear. You take the number here from the first row of the original matrix and you multiply it by the determinant. So remember, we got those right over here. They're right here. So when I write this out, I hope that it makes sense for you. So here we go. A1, the original value was 4. And so now we're going to multiply that by negative 12. Why negative 12? Because that was the determinant of the A1 minor. Now, here's what we're going to do. Next thing we're going to do is we're going to subtract. Why are we subtracting? Because right here in the second column, in the second row, you subtract. Now, what is our original value for the matrix here? It was negative 2. So I'm going to subtract by negative 2, like so. Hold on, let me go back. I'm going to use my original color here. I'm going to subtract by negative 2, like so. But then I'm also going to multiply this by negative 4. Now, sir, you're probably asking me, how did I get negative 4? Well, negative 4 was the determinant for B1 right here. We calculated this on the previous slide. Now we're almost done. The last thing we're going to do is we're going to add. Adding comes from right here. And so now we do plus, and then what do? Okay, we have the original value is negative 3, or is it positive 3? Oh, I'm sorry, it's positive 3. I need to fix that. Excuse me. Positive 3. Ignore that negative. Should have been more careful. So positive 3 here. Let me make sure that positive 3. So positive 3. Oh, excuse me. Gotta use my colors here. Positive 3. Now I'm going to multiply this by negative 4 because that is the determinant for C1. Excuse me. So I'm going to try to make my colors consistent. Negative 4. Now you can calculate this on your own time, but when I ran this through the calculator, exactly as you see it, we got the answer of negative 68. That is the determinant for this particular 3x3 matrix. So you can see that this is very fascinating. Again, the applications aren't that relevant for many of us, but it is a tool that you can use. So let me back up and explain what happened here, and then we can conclude this video. So what happened was that we started by looking at how to deal with the 2x2 matrix. In a 2x2 matrix, all you simply do is you multiply the diagonals and subtract them you find the difference, if you will. Not that complicated. When you move to a larger matrix, for example, a 3x3 matrix, you cannot, you can't do it exactly like that. So you find what we call these minor determinants, where you take combinations where you can, take different combinations of 2x2 matrices to find the determinant for a particular value inside that matrix. That's kind of how it works out. Now, after you do that, you do some addition and subtraction to find the determinant for the entire matrix. That's kind of how it works out. And again, this value is very, very useful when we get into solving a system of equations with matrices, usually things like Cramer's rule. In a practical context, often determinants were used for the purpose of seeing if a system of equations had a unique solution. That was one of the shortcuts behind them, and so that's what they grew out of. So I hope this video was useful. I know that it was kind of dizzy in terms of how we're working with things, and there's a lot of things going on. But again, this is just one of those fun things about math where you just have to kind of, follow along the best you can. My name is Darren Thomas. I am the Director of Educational Research Techniques. Take care.